Okay, this is the video to go over the worksheet 2B for Math 4. I had a colleague that actually had this as a poster in his room. Although I'm not even sure y'all are old enough to remember Grumpy Cat, but anyway. Okay, let's move on with the worksheet. We were supposed to use the rules that we had developed in the notes about describing the endpoint behavior. The fact that this first one, let me grab a color there, because it is positive and because it has an even degree, then we're going to say as x approaches negative infinity, y is going to go up, and as x approaches positive infinity, y is still going up. All right, so this next guy, it is negative and it is odd. Which means that as x approaches negative infinity, y is going to be going up. And then as x approaches positive infinity, y is going down. Okay, here we have a negative and an even. Which means that as x is approaching negative infinity, y is going down. And as x is approaching positive infinity, y is still going down. And then lastly, we have a positive with an odd. Which means that as x is going down, so is y. And as x is going up, so is y. That is straight off the first example from the notes. Now, let's see now, we need to describe the x-intercepts, give an appropriate graph, and include whether each intercept will pass through the axis or bounce. All right, so let's just kind of do what we did in the notes, because your x-intercept is basically the roots. You're going to have a root at -2 with a multiplicity of 1, which means that it will pass through. And then you're going to have a root of +4 with a multiplicity of 2, which means that it will bounce. Now, if I have one of these and two of those, and I multiply all of them together, I'm going to get something that starts out with x to the third. Now, the neat part about it is that most of the time they're going to give you the factors like this, x plus this, x minus that, which means that rarely will we have a negative coefficient up front. So we're either going to have positive and even or positive and odd. In this case, it's positive and odd, which means that I know that my endpoints are going that way and that way. So let's plot our two roots. We have a root at -2, and we have a root at +4. Now, we know that it's going to pass through the -2, and we know that it's going to bounce off of that guy and do something like that. Obviously the exact shape of the curve is probably off, but that is the general direction that it's going to go. It's going to come up out of the negatives, pass through this, do some sort of hump, come down here, bounce off of that, and go up into the stratosphere. So let's try another one. Now this time, they're giving us a -1 up front, which tells us that this is going to be a negative rather than a positive. So let's see, we got roots. We have a root of -3, multiplicity 1. We have a root of -1, multiplicity of 3. And then we have a root of +2 with a multiplicity of 1. Now, since these are all odd, they're all going to be passing through. And since we have an x here, and we got 3 x's there, and we got 1 here, 1 plus 3 plus 1, we're going to have x to the 5th. And that -1 makes sure that we're going to have a negative out in front. So instead of doing the usual wiggle like the x cubed curve would do, this is going to be backwards. That means that we're going to be coming up from this corner and going down out of that corner. And we're going to have x intercepts at -3 and -1 and +2. And all of these are passing through, so we're just going to pass through him and go through and up and down and out. So that is roughly the shape that this should take. I wasn't kidding when I said some of these have some wiggles in the middle. And if you saw in class, well, that's right, I may not have shown that in every class. I think in one class I pulled out Desmos and graphed it. And what we were doing in the notes that kind of looked like a W, the bottoms of the W actually stretched down to -64 or something like that. So, this is just an approximate shape of the graph. And we have no idea, how deep the valley is, how tall the mountain is. For all we know, it may go off the graph. But this is the general idea. All right, now on to some word problems. So we are going to be creating a piecewise function. All right, so we've got to write the function and then calculate the cost for 150 people. All right, so we're going to do f of x, and there are 1, 2, 3 different levels of this. So we'll start with this one, $40 per person for an event of 50 or fewer. And we figured out in several of these that that's $40 times the number of people. And then we're going to say for, you can't have negative people. I guess you could have 0 people show up. But it's got to be 50 or fewer. So that means 50 is included. So we've got that. And then the middle level, 51 to 100, cost is 30 per head. So we're going to say 30x for when, and I don't know, you could say 51 to 100. Yeah, I guess you could do that. Or you could say 50 is less than x, and then is less than or equal to 100. Because I guess you can't really have a half a person, not unless you're talking about like infants or something like that, that they would charge half, but there's no mention of that here, so we're not going to go there. All right, and then 100 or more than 100, 20 bucks a head. X is greater than 100. So now we have to figure out the cost of 150. Well, that sounds like it would be down in the blue category, where X is above 100. So 20 times 50, 150 is going to be 3,000. Yeah, 30 with 2 zeros on it. Okay. So I think we've done that one. Parking lot charges $3 per half hour with a maximum charge of $7 for 6 hours. Okay. Sounds like there's really only 2 levels of this. There's everything up to 6 hours, and then there's everything over 6 hours. So let's start with this first part. I'm trying to think how we would write this. That would be $3 if X equals a half hour. We're going to have to establish that. $3 per half hour for 0. And well, think about it, in a half an hour, if $3 per half an hour, that's $6 per hour. Wow. That's not going to, stop and think about it. If they were staying there an hour and a half, that's $9. That's more than the $7 for 6 hours. So really, you're almost going to want to say that. Well, no, half hours would be 2 of them. There are going to be 2 half hours that'll put you up to $6. And then anything above 2 half hours, you're just going to have a flat charge of 7. All right, let's see if we can put that together as a graph. All right, so this is y equals 3x plus 0, technically, which means we start here. And I guess if this is going to be a half an hour, then this is going to be 1 hour and 2 hours. Well, we want it to be 6 hours, don't we? So we might need to do it that way after all. 1, 2, 3, 4, 5, 6. We do want to be able to show for 6 hours here. So, and this, maximum charge of $7. Well, that's $1 per stop. So for the first 2 half hours, we're going up to $6, right? $3 for the first half hour, and $3 for the next half hour, which means that we are going in that direction. Now, why does that not feel like a 3x? Oh, I guess it is. Your x represents a half an hour. So that's going up 3 and over 1, which represents a half an hour. So we're having this business of the half hour is wreaking havoc with what looks like it ought to make sense. Now, from this point forward, anything that's above 2 is just going to be a flat $7. And so that's what the graph should look like. All right, so we created we wrote the function, then we graphed the function in the grid. And again, you'll notice that, when you are adjusting your units on X and Y so that it will fit the graph and fit the problem, that sometimes it may look a little funny. but you have to really check your points along the way. At 0 time, it should be a 0 bill. At the first half hour, that should be $3. At the second half hour, that should be $6. And then once we get above that, $7 covers everything. Now, I guess one question needs to be raised here is that if they say that there is a maximum charge of $7 for 6 hours, are they trying to tell us that you can't stay more than 6 hours? Is 6 hours the limit? I'm kind of drawing on the real world here and feeling like, I don't know of that many parking lots that, if you're going to pay flat $7 for 6 hours, that, they aren't going to kind of say that's for the rest of the day. So I'm going to leave that alone, but I'm raising the question because it is a fair question. Is there such thing as staying in the parking lot beyond 6 hours? They're a little vague on that, so we'll let it run with that. All right, I think, we got one more? Yeah, we got one more. All right. Cell phone plan offered by Burst Mobile gives unlimited talk and 500 text messages for $50, and then texts cost 10 cents a text after the first 500. Now, I will say this, that is kind of the way they used to do that. They got these plans where you get everything for one flat rate, but that's only because they kind of, the competition started making it to where people were offering better and better deals just to get people to jump to their phone plan. So let's start with, let's see, we got 2 levels of this thing. We have $50 that is a flat charge for the first 500 texts. So from 0 all the way to 500. And then beyond that, it's going to be $50 for the first 500, and then 10 cents for every text after 500. Now, here's where we got to be careful. It's not 0.1x, because you would include the 500 in that. You're actually supposed to take the 500 out of the x, assuming that it goes beyond it. And that would be for anything beyond 500. Now, I guess I'm used to doing this down below and simplifying it. 0.1x. 0.1 times negative 500 is negative 50. Oh, looky, looky. Those 50s cancel out. That just kind of made our problem look a lot easier. Yeah, 50s cancel, and all I'm left with is 0.1x. So all I really do have to do is, if Egbert is sending 800 texts, then that is going to be 0.1 times 800 equals $80. Because he paid $50 for the first 500, and he paid 10 cents for the next 300, which would be 50 plus $30. So it is 80. All right, now I think we're done with our worksheet for 2B.